Hello, ladies and gentlemen. Today we want to take a look at a little bit more of that vocabulary and make sure we're clear on some angles that occur inside circles here. So we want to take a look at arcs and their measures. Now we've already talked about arcs this year. We've talked about arc length. We want to now talk about it in terms of degrees. So I don't care if you write these notes down necessarily. We don't have a foldable for this, but something to write with and a calculating device would be beneficial, okay? So first thing to note or remember is that when we talk about arcs, we're talking about pieces of the curvy part of the circle, right? We found the length of these arcs before using our arc length formula. But I also want to point out that a minor arc is called a minor arc because it's less than half the circle, okay? But a major arc would be an arc that goes through 3 points like this, like A to D to B in that order, and that covered more than halfway around the circle, so that is called a major arc. The angle located here in the center is obviously a central angle, okay, because it's located in the center, by the center, right? And when we talk about this arc stuff, we want to be aware that there's some vocabulary that comes in there, okay? And a semicircle is an arc whose endpoints are the endpoints of the diameter. In other words, it's half the circle itself. So we have minor arcs that are less than half, major arcs that are more than half, and semicircles that are exactly half. So in this picture, we want to say whether it's a minor arc, a major arc, or a semicircle. So if I were to go from A to B, and it's kind of, this is supposed to look a little curvy here, okay? If I go from A to B, directly from A to B, the shortest distance, this would be a minor arc, right? Because it's less than half the circle. What if I go from A to B to C? So I have to go in that order, A to B to C. That is still a minor arc because it's half of the circle. What if I go from B to D to C? B here to D over here to C here. Well, that's more than half the circle, so that one we would call a major arc. What if I go from B to C to D? B to C to D, that looks like exactly half the circle, so I would call that a semicircle, okay, half. So think about that vocabulary when we look at some of the problems we have to do today. We're going to be using that. So when we talk about how we can talk about measurements of arcs, we can use arc measurement two ways. We can talk about arc length, that's how long it is, like in inches, centimeters, meters, miles, whatever it might be, or we can talk about it in degrees. So these two ways are the major ones that we talk about measurements of these arcs. For us today, we've already done arc length this year. We've already talked about how to do the degrees over 360 equals the arc length over 2 pi r. Okay, we've already used that formula, but now we want to focus on talking about it just in terms of degrees. So the measure of this arc, the degree measurement of this arc, is out of the 360 degrees, right? But the arc measurement is always going to equal the measurement of the central angle across from it. So if there's a central angle here of 50 degrees, that means the arc piece across from it is also 50 degrees of the whole circle, or 360. Okay, so if we want to figure out the measurement from here to here, we'd say, well, that's 50. If I wanted to figure out the measurement from A to D to B, well, that'd be everything but the 50, right? So 360 take away 50 would leave me with 310. So when we look at these arc measurements, we want to be aware of how to find them in degrees. So I have a central angle here of 135. This central angle here would be whatever's left, right? Out of 135, this is a straight line here, so that's 180 or half of the circle. So this guy right here would be 45 degrees. And this over here would be 180. So when it says we want to find the measure of each arc, that means in degrees, okay, not the length, but the degree measurement. The measure from arc D to B, that's the shortest way possible, so D to B, I would just say that's 135 degrees. What if I go from D to A to B? This way. Well, then that's 45 plus 180, right? So we'd have 5, let's see, 225. And what if I go from A to D to B? Well, that'd be exactly half the circle, which would be 180 degrees. So remember the order here tells us what order we are traveling around that circle. If it has 3 letters, make sure you hit all 3 before you figure out the number of degrees. Now, what if we have this nicely evenly divided piece here? Well, what's happening here is that this is kind of like the spokes on a tire, a bike tire. So what we have is each of these is an evenly spaced piece, right? So how many degrees would each piece be if we know they're all evenly spaced? And I know they are because the measurement of the arc across from them is all the same. Well, each one of these would have to be 45 then, right? 45, 45 makes 90. Here's another 45, 45 making a 90. 45, 45 making a 90. 45, 45. So when we add all those up, it makes 360. So if I know that, then I should be able to find the measurement from E to F to G. The shortest way possible, that would be 90 degrees, right? Two 45s added together. All right, so the last thing to think about is what it means to be a congruent circle. And congruent circles have to have a congruent radius, right? I could draw a circle here and have it a radius of 2, and another circle over here with a radius of 5. Those are not equal circles, right? One's obviously bigger than the other. They have to have the same radius. Congruent arcs, however, are arcs with the same measurement degrees, okay? So arcs with the same measure in the same circle or in congruent circles, arcs with the same measurement degree, we want to make sure that they are in congruent circles in order for us to say that they're congruent arcs, okay? So are arcs C to E and E to F congruent? Explain why or why not. So C to D right here and E to F, would they be considered congruent arcs? And the answer to that is yes, right? They're both across from a 45-degree angle, so that means they're 45-degree arcs, and they're in the same circle, so it's not like the radius changes as you go from one side of the circle to the other. However, in this picture, we have a circle in a circle, concentric circles. The measurement from C to D is 110 degrees, and the measurement from E to F is 110 degrees in the bigger circle because they're both across from the central angle of 110. But because little circle inside here is smaller, the measurement from here to here, this length, would be obviously smaller than this length. So they are not, in fact, congruent. So make sure that they're in the same circle and make sure that they have the same radius. So would C to D here be congruent to E to F here? Yes, they're across from the same central angles. These angles would be the same because they're vertical angles. So we would say that those two are in fact congruent. Okay, I want to thank you for watching this little video, people. We'll be working with some arcs and finishing up any old work today. Don't forget that tangent video, or don't forget that tangent worksheet from the day before, okay? I want to thank you. Kincaid out.